Awesome. Hello, kia ora. Welcome everyone to today's campfire session. We're really excited to have you here as we dive into the introduction of AI for leaders in ECE. We're thrilled to have Ella Greer, who is a customer engineering specializing in AI and ML at Google Cloud, where she helps businesses tackle complex challenges with transformative AI solutions. Ella is a passionate advocate for leadership and innovation. Her career spans leadership training, social business development, and tech-driven impact projects in places like Cambodia. Ella has a strong background in advanced computing and biochemistry, and Ella brings a unique perspective to the intersection of AI and education. Today, Ella will share insights on how AI can revolutionize early childhood education, empowering educators and shaping the future of learning. So Ella, I'll now hand it over to you.
Awesome. Thanks very much, Jen. And thanks everyone for joining. I'm keen to spend a bit of time diving into a few different AI concepts today, just giving you a bit of a 101 and sharing a bit of my experience in the industry. Sorry that we've kicked off a little bit late, so I'll try to move through a little bit more efficiently, but feel free to jump in and ask questions as you have them, pop some thoughts in the chat. I am joining from a brand new tech setup, my partner's laptop today, because my Google laptop appeared to be quite allergic to Zoom. But if we have any difficulties throughout, appreciate your patience. And just let me know if at any time you can't see any of the content that I'm presenting. So I'll share my screen now. Has everyone got that clearly there? You can see.
Ella, I just can't see it. Would you mind just sharing it again?
Yeah, for sure. Let's try one more time.
No, it doesn't seem to be working.
Okay, let's try again. A different type.
No, it doesn't seem to be working. Would you like me to share for you, Ella? Would that be helpful?
Yeah, maybe. And I'll just say next slide as I go through. And
just feel for the prompt. That's all good. All right, I'll share my screen now. And just confirming everyone can see that now?
Yep, got that.
Awesome, thanks team. All right.
Awesome, let's get into it. Next slide, please. So I'll just, go back.
Sorry.
Awesome. Just quick introduction so that you can learn a little bit more about me and my role at Google. I'm Ella. I'm an AI specialist within Google Cloud. My job essentially involves working directly with different types of technology companies across Australia and New Zealand on designing and implementing their AI principles, strategies, and roadmaps, and essentially using Google's technology to bring some of these ideas to life. Outside of that core role that I have at Google, I actually do a lot of work with Google Education Australia as an advocate for how AI can transform how educators are making use of our workspace tools and platform in the classroom to deliver a more personalised experience to educators and to students to alleviate the increasing demands on educators as well. And it wasn't until last year that I had the pleasure of working with some of the Love Heart team through our AI accelerator that I saw how this impact could be carried across to early childhood learning. So I really feel this team have an intimate understanding of the problem space, and the way they're using AI technology is really awesome to see. Today, I'm excited to spend some time setting a little bit of context on how the era of technology that we find ourselves in is really accelerating, and why the conversation on AI is increasingly coming to the forefront for a lot of different use cases. I want to give a little bit of an overview and a 101 on how AI technology works, and specifically how we kind of got to large language models as a very popular type of artificial intelligence. And as a result, go through kind of some of the use cases that have emerged and what we should be prioritizing and focusing on broadly. So let's get into it. Next slide, please. Awesome. So to step it back a little bit to start off with, does anyone recognize this train station? You can almost see the name for it Feel free to chuck it in the chat if this is a location that you recognize, perhaps maybe if you're based down in Melbourne. I'll open up the chat here to see if we have any guesses. Yeah, so my comments might be disabled for this, so I'll just press on. This is essentially, this is Flinders train station, but it's a photo taken back in the year of 1993. And so if you take a minute to look at this picture and think, what's wrong with it? What's something that might be out of place? Maybe if I flick to the next slide, the difference will start to become a little bit more obvious. So fast forward another 10 years to a new photo taken outside Flinders Station in 2013. It's clear, what was wrong with the first photo. In 2008, the iPhone launched in Australia, which was a little bit less than 15 years ago. And this is what life looks like now, or even in 2013. We're always on, always connected. And for the most part, the phone is almost an extension of our hands. And there's an obvious story here around, the pace of innovation and the pace of technology. But I think the other is how quickly we evolve our systems and behaviors. I think it tells a story that tends to surprise most people, which is that we're actually very good at change as humans. And in not even 6 years, we completely adapted our lives to the reality of the smartphone and this always on real-time existence. Next slide, please. So the reality is that historically, this adoption or speed at which we evolve our systems and behaviors around new technology actually gets faster and faster. This graph shows the years until which 50% of US households had adopted new technologies from when they were first released. So we saw around 6 years for the mobile internet era. And it's anticipated that AI will be ubiquitous in every household within 3 years, which is just half that of the mobile internet when we think about how quickly that, disrupted our lives. And next slide, please. So the idea that this kind of AI adoption might take place in the next few years for us is a little bit scary, because the reality is that generative AI applications today feel a little bit like what Henry Ford in this photo looks like riding his first quadricycle automobile. Much like this is the starting point for the modern automobile, the generative AI applications that we're seeing today are really laying the groundwork for even more transformative technologies into the future. But I think by taking a bit of time to understand the fundamentals and exploring the applications that we're seeing for some of this new technology, we can better appreciate the potential and the momentum that is going to take place in this next technology shift. Next slide, please. We're now standing at the precipice of really this next shift in technology, one that has potential to change our systems, our behaviours, just as profoundly as the birth of the web or the move to mobile. And this shift is really being driven by AI. Next slide, please. But an important thing to note is that this idea of artificial intelligence or AI didn't just pop up overnight. It's actually been around for a while. The CSIRO implemented their first AI use case in, I think, 1974. Netflix, when you switch it on of an evening, 80% of what we watch is being driven by AI recommendations. When we type a couple of words into Google, expecting exactly what we're thinking to pop up in the first few results, that's all AI-driven systems and technologies. When we trip over our new robo vacuums in our homes, those types of technologies are being driven by AI. But what has brought about this inflection point is an incredible breakthrough in specifically generative AI technology, which has opened up a new era of AI. And there are a lot of reasons why this has been so profound. And one of the most profound is that much like the internet and mobile technology, generative AI has really given us a new interface to consume information, and one that we're a lot more familiar with, which is language and conversation. Next slide, please. And even still, the foundational research for generative AI actually did happen a number of years ago. in 2017, Google's DeepMind, which is the research center that we've kind of built around AI that drives a lot of our innovation, published this breakthrough paper on natural language processing that outlined something called transformer architectures, which is where this research field started to accelerate. But it wasn't really until like 2022, so about 5 years later, that it started coming into popular opinion. And there are a few driving technology factors for this that really have created the perfect storm in what we're starting to see accelerate at the moment. First, we have cloud computing. And cloud computing technology has really matured pretty significantly in this time. It provides the infrastructure to train and deploy these massive AI models. And we can really think of it as the engine that is powering this AI revolution as it goes. It's making development much more accessible to a much wider audience and starting to really democratize the field across the board. The next kind of enabling technology is GPUs, non-coincidentally why we've seen the stock price for NVIDIA go up so much over the last 12 to 18 months. But they were originally designed for rendering images in video games, but have turned out to be super effective at handling parallel computations required for training large language models and AI systems. And then finally, and perhaps most importantly, is actually the access that we have to the amount of data required to train really good AI models. They're trained on massive data sets. So if we think about, the level at which the internet is currently generating knowledge and information, it wasn't until recently that we actually had the requisite data to train really complex models for more advanced reasoning tasks. So it's important to kind of consider all of these enabling factors and how we got to this point. Next slide, please. This groundswell ultimately came to a bit of a tipping point in late 2022 when OpenAI released a chatbot to the public in a way that allowed us to interact with this type of research and this type of technology for the first time. And it was really crazy to be working at a company like Google in this time, because somewhat of a massive frenzy began in popular opinion, where we started to see how advancements in AI could actually impact our work and our lives in really meaningful ways. Next slide, please. This isn't necessarily about, AI will take our jobs and replace what we're doing and all of those sorts of things. It's really about, augmentation. AI is essentially this really powerful tool that can amplify your abilities to help you achieve more or, something different in different concepts. Think of it like adding a superpower to your skill set. By learning to work alongside AI, you're not just kind of staying relevant and up to date with new technology, but you're broadening certain skills and breadth in the knowledge work that you might undertake. Next slide, please. Now, I kind of want to pause here and go into a little bit of what we were talking about before around what is AI, and a bit of a 101 as well. It's actually become a bit of a loaded term, I would say. We hear a lot of associated terms, from LLMs to Gemini to GPT to neural networks, etc. And so I want to spend a little bit of time explaining how these terminologies relate to each other. Artificial intelligence is really like a blanket term that captures any type of technology that is a simulation of human intelligence by machines, particularly computer systems. And so as a result, it encompasses a whole bunch of different technologies. Next slide, please. Machine learning is essentially a set of methodologies or techniques that are a subset of the AI domain. So the practice is essentially focused on allowing computer systems to learn from data and improve their performance on specific tasks without explicitly programming those tasks. And we'll talk a little bit more about what that means. But say, for example, for weather forecast prediction, if you have a whole bunch of historical data and some recent inputs, you can predict, what the weather is tomorrow or next week, albeit pretty unreliably from our weather systems. But you can't explicitly program exactly what you know the weather to be tomorrow. It's more about these prediction type tasks that don't rely on explicit programming. Next slide, please. Now, as we mentioned, some of the first ML models were created ages ago, as early as the 1950s, but it wasn't until around 2012 that a new technology within machine learning was introduced called neural networks. And they're essentially a type of model within the ML domain, inspired by actually the structure of the human brain with different interconnected nodes or neuron cells organized into layers which process and transmit information, much like the neurotransmitters in our brain. And this kind of new architecture enabled what people have probably widely known as deep learning. Next slide, please. So within deep learning, there are a huge number of different models and types of techniques that started to emerge. There's a whole bunch of different ways to do deep learning, from natural language processing with models like BERT, which was one of Google's first NLP models, to diffusion models, which are focused on how to create images from text, to convolutional neural networks and so many different others. But there is one very popular type of model within neural networks as it stands called large language models. Now, they're a type of model that takes in massive amounts of unstructured text data with the goal to essentially understand, generate, or manipulate language in some kind of way. And to take it the last layer deep, next slide, please. The transformer architecture is really the most popular type of large language models and is the basis for a lot of the most popular models that we see in the industry today. Next slide. And it's useful to kind of note that this field of research really progressed in this direction of specialization. We firstly had these more simplistic machine learning models like decision trees and gradient algorithms and those sorts of things, which subsequently evolved to neural networks, which were capable of handling more complex tasks. And ultimately, some of the most difficult but important tasks to achieve were based on language, which is more difficult to model numerically with a lot of nuance and complexity. And so this is where natural language processing and LLMs came to the forefront. I'm going to go a little bit more into that in a sec, but this is sort of how the field has evolved to date. Next slide, please. So Google's most advanced research in large language models is essentially something called Gemini model. Now, Gemini models are kind of this transformer-based architecture that is natively multimodal, meaning they're designed from the ground up to process information from different modalities, including text, but also images, audio, video, and analyze those things simultaneously to reason across these different modalities. And in the context of Google, we've built the Gemini family in a range of different sizes and specializations to optimize for specific types of tasks or resource constraints. Next slide. And I kind of want to pause here to make an important differentiation as well. For anyone who's kind of coming across a lot of different types of LLM-based technology in the industry. For anyone here who might have used the Gemini application, some people tend to confuse the AI models themselves with the interface through which they are interacting with them. At Google, we have a Gemini app, so you can download on your phone or log on online and kind of have this chat interface. And in this context, our Gemini models are optimized for everyday consumer use, whether that's to plan a holiday itinerary or create a recipe using what you have in the fridge. Very similar to the way that you might interact with ChatGPT, for example, as well. But we also have a version of these Gemini models that are available via our enterprise platform, which is called Google Cloud, for companies to be able to pick up and use Gemini technology for their own use case that might not be optimized specifically for chat interactions, but might be really useful for metadata analysis or for, particular types of use cases. And we're always updating and making these models better. Though the chat interface for Gemini may not change, week on week, we're releasing kind of more advanced complex reasoning models. Like I think just over a week ago, we released Gemini 2.0, which is our most advanced version of that reasoning capability to date. So the underlying technology is kind of always evolving to come through in these different use cases that we build, for chat and for different contexts as well. Next slide, please. So I spoke a little bit more about this evolution of LLMs, and I'm keen to just double click on that a little bit further to illustrate why they've really become the focus of the field and some of the use cases that are being enabled. Next slide, please. So essentially computer intelligence, or this idea of AI, started with more traditional rules-based programming. So like you see on the screen here, we know if we're trying to analyze or predict if someone's walking versus riding a bike, we can probably, calculate a few rules-based. If they're walking slowly, or if they're moving slowly, they're probably walking. They're moving a bit quicker, they might be running, and kind of, program these sets of rules. And for a long time, this worked really well. But let's just say that person's golfing or they might be swimming. How is it possible that we're going to detect those sorts of things? In reality, the real world is quite messy and more complex than can really be represented in these sets of rules. Next slide, please. So that's when we move into what's called narrow AI. Some people call this weak AI, but it's more of a narrow-based approach where AI is trained to do one task very well. Next slide. And people got really excited when neural networks started to be able to take on some of these messier pattern recognition type tasks. For example, if you want a computer to recognize what a cat is, you'll need to gather lots of pictures of things that are cats, as well as things that don't look like cats at all. And it learns to recognize those patterns of pixels as they're gathered together. And it's super useful in a lot of very deterministic contexts where we need to be really precise. But it essentially is a little bit constricting in that it's a fairly narrow approach to specific tasks or concepts. For example, even though it can be, next slide, please. Even though it can be quite specific, it still requires a massive amount of data to be able to handle that nuance really well. Next slide. Even if you want to, recognize the difference between a dog and a mop, there's still a lot of kind of nuance that needs to be managed there. Next slide, please. And you can imagine how these types of tasks become quite difficult to solve for as you want to expand them out to lots of different use cases. Next slide, please. So when we started to apply these neural networks to more cognitive tasks, the world of gaming was a good place to start. And this is sort of how neural network or narrow AI evolved into self-learning and more general AI. So DeepMind first started building an algorithm called DQN. And the team trained DQN to play a raft of different Atari games like Pong. Pong is this game that you see here where you're essentially trying to get you have your little controller at the bottom and you're trying to knock as many blocks away as you can. And what was different about this DQN approach is we were trying to optimize for self-learning, so not for specific already identified tasks and outputs. And so when you're training a model to self-learn, at first it seems pretty hopeless. We can see here from 10 minutes of training, it's essentially no better than random luck in terms of how efficient it is at actually achieving the tasks that it's set out to do. Next slide, please. But once the self-learning models stumble upon a rewarding action and start to optimize for that action, it starts to become pretty precise. And so you can see here at 120 minutes of training, the model has gotten pretty good at playing the game to a relatively good level. Next slide. But as you continue to optimize on this path, and something that was a research breakthrough at the time, something pretty remarkable happens. Without directional training data, DQN on its own was able to uncover a particular strategy that would probably only occur to someone who's an experienced Pong player. As you can see here, it's played through a couple of times. It essentially began targeting a specific row of bricks to create an efficient route to the back that enables the ball to simply bounce off the back and destroy the entire set of bricks in one swift frenzy. And this was really the first time that we saw a neural network teach itself something new and pave the way for more general learning strategies that we've optimized for with the large language models. So next slide, please. This self-learning effect, coupled with a few other advances in how we represent language mathematically, set forth a way to a more general or strong AI, which instead of being good at very specific tasks, may be good at many tasks. Next slide, please. Generative language models are a different approach. You feed a lot of text data into a model that results in not a finite and conceptual number of parameters, but several hundred billion to a trillion parameters. And what's remarkable is that these language models learn a seemingly endless number of concepts. And when you poke and prod at them, it feels like they've developed this foundational intelligence that's based on language and could enable all types of new things. Next slide, please. And what this complex neural network essentially is doing is really good at determining what the next word should be. And though, I'm just checking let's see if a couple of messages come in here. Yeah, I'm noting we've only got about 13 minutes left, but I'll kind of move through quite swiftly and hopefully we won't go too far over. What this network is doing is essentially getting really good at determining what the next word should be. And though when we interact with these large language models, they're very useful at achieving certain tasks for us, it's useful to think of these tools as a very nuanced next word predictor, where every token or word that is produced by an LLM is essentially an inference or a prediction of the most probable word that should occur in that sequence based on all the previous words that have occurred. And so all an LLM is doing is essentially taking your prompt and from the last few letters of your prompt, or last few tokens of your prompt, I should say, predicting what the next set of tokens should be. And there are a few ways that you can tweak this probability using parameters like temperature, which you might have come across. But essentially, this kind of probabilistic prediction set is the way that a lot of large language models are founded. Next slide, please. And when we amalgamate these two fields, so essentially, traditional and generative AI, we can start to achieve some pretty awesome use cases because traditional AI or task-specific AI models are really good at things like dynamic pricing, fraud detection, trading, ad spend, while more generative AI systems allow us to achieve more complex reasoning tasks or perhaps creative tasks and optimizations. And these two systems and types of technologies are almost reminiscent of like left brain, right brain type thinking and can be paired really well together to build really fluent AI systems. Next slide, please. In summary, traditional AI is trained on, specific data set for a specific task, while large language models are trained on massive data sets for a huge range of tasks and may be able to achieve tasks that they were not specifically trained to do. Next slide. And a really big reason for the popularity of generative AI is that this wide range of tasks allows us to take on a lot more quickly when it comes to building AI systems. For instance, creative agents that can produce product descriptions from images or blog posts or kind of release notes for your development cycle and those sorts of things. They're able to summarize, to ingest information in a more succinct manner, or create an intranet Q&A. You can create discovery tools a lot more easily by being able to search content in a lot more semantic manner, and automating different types of tasks that you might want to achieve, and conversing with documents and those sorts of things. And we can start to build these types of use cases a lot more quickly with some of these new AI tools. Next slide. I believe Google did a study with McKinsey in joint at the end, or like towards the end of 2024, to kind of do a pulse check on what percentage of the workforce, admittedly this is in the US, are currently using AI across different types of tools and processes. And so these percentage indicators show us, where AI is most popularly used, for instance, in customer service and chatbots. But we can see here that a huge percentage of knowledge workers across software development and other business domains are using AI to increase general efficiency, to do things like data analysis a lot more quickly, and to generate content in the context of marketing and ad copy and those sorts of things as well. A really big use case that we're starting to see at Google, if we go to the next slide, and another really big reason why LLMs have become so popular, is because they have an ability to understand and reason across a huge amount of unstructured text, as well as multimodal data. We're living in a world where, digital information is exploding, and it's hard to find and understand the most relevant information that we're looking for when we're looking for it. And in conjunction to that, and I'm sure in an education context as well, increasingly our paper-based systems are being brought online and really adding to that historical knowledge repository of information that we need to find and often reason about. And so what some of these LLM tools and embeddings-based systems are allowing us to do is, next slide please, taking all of our unstructured document data from thousands of PDFs to images to articles to reports, and often across different knowledge systems as well, and pull it into a central storage location. So next slide, please. In the context of Google Cloud, say, for example, you can upload a bunch of unstructured document data to a specific storage bucket or location or that sort of thing. And then, next slide, please. You can start to reason and ask specific questions of this knowledge repository. So you can use generative AI to, understand the full corpus of information, retrieve relevant results, and then use those results to inform and formulate a natural language response. And these are the kind of systems that this technology is now enabling. It's built on an architecture that's essentially broadly called retrieval augmented generation, and relies heavily on natural language processing tools to be able to build those types of systems. Next slide, please. So we're seeing that this technology is enabling a lot of new use cases across the industry. And it's actually kind of hard a lot of the time to know where to start. Working with a lot of different technology companies, it's difficult to identify the exact areas where value will be realized while also being able to control for risk. And so this kind of 2x2 matrix, it does look different in different industries and different types of businesses, but it's often useful to think about where the types of use cases that you might be thinking about for this technology exist on this matrix here, where you're thinking about, where the business or customer value may be realized for your specific tool or set of things that you might want to build, and where the risk exists to introducing AI technology to achieve that specific task. And next slide, please. When you start to map these out to what might be the priority wins for those specific use case, we see a few of the top, most popular items pop up here. And I'll call out knowledge discovery as well, because this is a huge area that we're seeing people invest in a first instance. Intranet knowledge and discovery is a huge high value use case and can be implemented with relatively low business risk. Oh, yep. I saw Himal raised a hand.
I was just going to add to that, Ella. Knowledge discovery, just from the Mana perspective, is a huge part of what our platform enables for educators and teachers, which is being able to see kind of the learning of their child within context and bring, the whole knowledge of the internet into that moment where they can then go, hey, okay, I noticed this. What does that actually mean about this child? What does that relate to, etc. Just to kind of give context to the group in terms of, what you mean by knowledge discovery there.
Yeah, 100%. And I've seen a couple of Q&As have popped in here.
Maybe we, Ella, maybe we jump to those at the end.
Yeah, okay, that sounds good.
Cool.
And I see if a couple of them actually relate to this idea of like, now that we, are trying to identify the risk or prioritize certain use cases and things that we're trying to build. If we jump to the next slide here. Core to this kind of process is correctly identifying the risks that exist with adopting new technology. We need to ensure governance is in place, that we properly understand the challenges and limitations of this technology as it evolves. And so we need to assure these are well understood by a huge range of different stakeholders, which can be, specifically a challenge in early childcare and that sort of thing as well. So next slide, please. If anyone's, had a go at GPT or Gemini, perhaps, you might have noticed this, but the reality is that there are a few shortcomings of large language model technology, everything from biases that may exist to their ability to do maths is not great, to, hallucinating and sometimes producing output that isn't aligned to a specific data set or set of truths. To, the factuality and the recency of what they might produce as well. Next slide. And what this results in are a lot of different risks that come to the forefront. And there are probably more risks than we can call out on this slide here, but I've outlined a few examples of the types of risks that we collaborate with companies like Loveheart in trying to, control for and manage at scale. And, in integrating this technology. Some are managed at the platform layer within Google. So if you're, picking up and using different types of Gemini models specifically or other types of AI technology, we manage things like copyright. So ensuring that, all AI is trained on data without infringing on copyrights and IP. To, ensuring that the environmental impact of AI from training to inference is managed with efficient compute resources, to the kind of security, like IT security that we inbuild into our cloud platform, being able to manage the sensitive data and data leaks and those types of things that you might open yourself up to. But we also collaborate with companies like Loveheart, who are building specific tools for a specific industry. How do you actually build into the application layer to manage for things like hallucination and accuracy, and being able to build systems that are grounded in an enterprise truth or knowledge set, so that AI doesn't go and produce outputs that may not be recent or may not be relevant to a specific task or use case. But it's worth noting, if you're part of an organization now who is thinking about the types of tools that they could pick up and use related to AI, some of these risks need to be managed at an organizational layer. For instance, you might have staff in your business who go and use certain AI tools without proper guidance or supervision of the types of AI tools that they might be using. And so some of these risks are managed, at the user level as well. Next slide, please. I think the second most common thing outside of risk that we tend to speak to different businesses and organizations about is actually like the talent and all implications of introducing this type of technology into the business. Next slide, please. Generative AI success isn't just about the technology. It's about having, the right people and empowering them with the right skills. The talent gaps in AI are essentially a major hurdle at the moment, and require a lot of new specific skills to be able to integrate well, and to maintain a lot of these new business demands that exist for, human centricity and ethics and bias and those sorts of things. And so this is a massive area of investment we're seeing across lots of different industries at the moment. And I'll just go to the next slide here. When it comes to how to unlock value from these new types of technologies and systems, my biggest piece of advice, and maybe one that I'll leave you with, is there's no need to kind of overhaul everything at once. The best approach in terms of starting to integrate some new technology into your context is to start small, to demonstrate impact, and to scale iteratively. Start by aligning and defining a really clear vision of what you want your AI kind of strategy to be. What are the goals and what direction are you trying to set? Experiment early. So focus on small, focus test, low risk exploration that's specific to your context, and continue to pilot and implement successful experiments and learn and iterate upon those, which is crucial to kind of building some early momentum when it comes to integrating this technology. And then, expand and scale some of those learnings across different parts of your organization or business context as well. This is a series of small steps, not a giant leap, to be able to prove value and learn and iterate in the context that you're in. This kind of rollout is where we've seen people be most successful when it comes to integrating generative AI. Now, I'll skip to this last slide here. I have a short video, but we might be better just going to questions perhaps. Oh, do you want to pause the video there?
Thanks, Ella. Ella, we might go. Thank you. Firstly, thank you so much for that incredible presentation and really helping, our audience. Our audience at Campfire is so hungry for knowledge and helping us really understand what AI is. And a couple of the takeaways for me is the difference between weak and strong AI. This idea of, I remember on my phone 10 years ago, my phone could tell the difference between my face and my mum's face, right? So like that kind of being like weak AI, and then like this new strong AI where it feels like it can do so much with Gemini and ChatGPT and so on, and kind of having that open-endedness to it. I think that was one big takeaway. Another big takeaway was really encouraging our audience to experiment with AI, but also thinking about the safety considerations around that. And I think just to bring some of our sector's context into that, we have a lot of participants here who are really interested in maybe trying out AI tools, but we also have considerations around privacy and security of data for children, et cetera, that are so critical to our sector. Particularly given our regulatory context as well, but also safeguarding their rights long term. So, being able to balance that is critical. So thank you for really opening up that space for us. We have a couple of questions. Maybe we'll start with the question from Lisa. This is a real curly one. So Lisa said, if AI can do something that it's not taught, what happens when AI talks to another AI and they create their own language? Maybe we can talk a little bit about safety and how, companies like Google and so on are addressing that.
Yeah, it's a great question. And you know what, Lisa, there's lots of articles online that suggests, this is a direction that some AI research is going, and the whole agents and when they start talking to each other and those sorts of things. But I do want to dispel like the fact that that is where a lot of AI models are going in the context of this research as well. I think the important takeaway that I was trying to instill there is not necessarily that they're coming up with all these new things that are never seen before, but maybe identifying patterns in really huge amounts of unstructured data that wasn't so obvious to us, because as humans, we can't conceive the amount of data that some of these AI models were trained on. And so that understanding of new patterns is really a tool that we can use to our advantage in the context of building some of these AI systems. And in the context of Google, we have a lot of kind of safety tooling and responsible AI practices that kind of prevent those more doomsday use cases that probably like seem to come to the forefront when we think about those new techniques. Some of which are, for example, we run about 35 classifiers upon every output that Gemini produces to understand the extent to which it adheres to or doesn't adhere to like our safety and responsible AI principles and those sorts of things. And I think those kind of guardrails and tools do enable us to at least identify when we're starting to see patterns or behaviors emerge from these new AI technologies that need to be steered in a different direction.
Thanks, Ella. There's a question here from Rose that I would love to take. If I know this is
yeah.
I'd love to take.
Yeah.
What guidelines should be in place for ensuring AI remains a support tool rather than a dominant presence in early learning? Rose, it's a really, really good question. And I think, over the next 5 to 10 years, we're probably going to settle into and understand more about the place that AI will play, or the place or the role that AI will play in early learning. We're definitely at Mana seeing some huge impacts and benefits of AI, particularly around supporting educators with their understanding about children's learning and supporting in thinking, improving thinking and practice, and of course saving time in a sector where we're notoriously time poor. I think that the government's doing some great work in this space to regulate the high risk areas of education as well. So I was involved in a consultation with the Australian government to ask what guidelines and guardrails should be put in place around the use of AI in early childhood education. And there'll be some movement on that probably this year, if not early next year, around some guardrails where the government is essentially going to say, look, we should be using AI in, we could use AI in these scenarios, but in these reserve scenarios, we need to have very clear guardrails in place to make sure that it doesn't go out of hand. So that's coming up shortly. And remember, of course, our use of AI still doesn't change the national quality framework or the standards that we need to adhere to. It doesn't change our requirement to adhere with privacy law as well. So, for those of us that are using ChatGPT, really important to remember that that data is getting stored not in Australia, and we have a requirement to store any data related to children and their learning within Australia. So there are some things for us to consider there around our use of those kind of tools. But I think in terms of pedagogy, I think there's a huge focus. I reckon there's 3 things for us to think about. One is helping our educators and teachers understand what AI is and what it isn't, and what role they should play if they're using an AI tool. AI can't make decisions for us. We are still the professionals and the practitioners. So it's our responsibility, if we are using an AI tool, to make sure that we're still exercising our professional judgment, just like, we would expect a doctor to do so if they were using an AI tool. I think the second thing is, as an organization, thinking about where you feel comfortable with the use of AI. Some organizations really want to leverage the benefits and they're thinking about what the downsides are, and you might be more risk averse or less risk averse, and that's really an organization question. But as leaders, it's probably our job to start that conversation and start putting guardrails in place as well for our organization if we do see there to be risks. And of course, at the sector level, for those who are in our session earlier today, there's a lot of regulation and so on coming to support us at the sector level, and I talked to some guardrails before. But yeah, I hope that answers that question. Zahira, you have your hand up. Zahira, would you like to throw yourself off mute and we'll get you to ask a question? Zahira, are you with us? Okay, it doesn't look like we have Zahira. Okay, well, I think that's it. Yeah, we're out of time, team. Ella, I just wanted to say a huge thank you for taking the time to really upskill us and help us build our AI literacy as a group of leaders here at Campfire. And yeah, we really appreciate your time, wisdom, and generosity in being here. So thank you so much for being here and being part of this conversation. To everyone here at Campfire, that concludes. Oh, sorry, no, we have another session coming up. Jen, when's our next session?
Yeah, so thanks everyone for attending. Our next session for Campfire will be how Oxander is empowering its educators with mana, and that will be happening at 2 p.m. Australian Eastern Daylight Time. So we hope to see you all there.
Thank you, everyone, and thank you for joining. Thanks again, Ella.
No worries. Thanks,
Thanks,
guys.
Ella. Awesome.
See ya.